Hello, welcome. Episode number 22, still on motion under gravity of the tutorial on dynamic mechanics. So a stone is dropped from a height of 32 meters. At the same time, another is thrown vertically upward at a speed of 42 meters per second. So first question, at what height will the stones pass each other? So one is dropping, one is going up. So at what time? So we are looking for the time at which the first one is dropping, the second one is going up, where they will be in line. Then at what we are looking for that height. Then the time will the stones pass each other. So we are all is talking about at what height or time will the two stones bypass each other. So let's see if we can make a sketch of that. Let's see if I have this as a, let me see if I have the height being taken. The height is going to be 32 meters, right? And at this point, a stone is going to drop. So we are going to have this here, and another stone from the ground is also going to be projected, right? So stone drop and a stone up. We are looking for this distance. Let me bring it up so that I'm not by any means saying that the distance covered by the upward movement is longer than that of the downward movement. It's just a sketch. So yours can be the other way around, where this will be longer or equal. It's a diagram. After solving, before we know whether the distance covered by this is a lot longer or shorter by that. So let's see if this is what we have. We have initial velocity here as 42. So I can have my u as 42 meters per second. Then here the initial velocity is going to be 0, because we're not told the velocity at which it is being projected down or dropped. Then what again is needed? We can also say that we can pick this as the height as a variable and subtract it from here to get the one that the upward movement will be, or we just pick the down upward movement. Let me label that word h. Then this is going to be h minus what? 32, if I'm to take this side. All right, I think the diagram is not that big, but the concept is what I'm trying to put across. So the distance that they are apart is 32. This is let down with velocity of 0. This is projected up, velocity of 42. Then we can say that the distance here plus the distance here give us a total of 32. So we can hold on to that. So the information provided here, if I'm looking at a stone drop, distance is mentioned, the velocity is also mentioned. We are thinking about the time as second question. So these three things being mentioned made us to think of which of the equations that can be applicable. Equation 1 will not be applicable because of the final velocity. Equation 2 can be applicable, time is there. Equation 3 will not be applicable because time is not mentioned. So I am going to say that for the stone dropped. Now, if we are looking at a stone that is dropped, let's bring out the information we outlined in the beginning. We have the distance, which is going to be from here to here. This plus this will be double h, so it should be 32. The longest side is 32 minus the one we are picking here. So rather, it should be, what will it be? 32 minus what? H, rather, not h, because if you add these two, we still get this negative h plus h, 0, then 32 will come. So that means I should be having 32 minus h. What information we have will be U is 0. Let me just leave it that way. Okay, we have acceleration, which is the same as the gravity because it is moving in direction of what? The acceleration. The acceleration is moving in the direction of what? The force of gravity. So that still remains 10 meter per what? Second square. What else is needed? The time. Time is also unknown. So we can just say from equation, in first equation, make use of velocity, final and initial time, no distance. Second one, make use of distance, time, and acceleration. The third one, make use of velocities, initial and final, acceleration, and what? Distance, no time. So let's use the S equals to ut plus half this square. We are using G because we are force motion under what? Gravity. So by substitution, this become 32 minus h equals to initial velocity 0 multiplying time 1 over 2 times the gravity, then t squared. Fast forward, 32 minus h, this will give you 0. Half of this is 5t. So we are having two unknown in this equation. So we make one of them the subject, or one in terms of the other. Meaning I am going to maintain this. When cross, it become what? Positive. This become negative. So h will become 32 minus what? 5t squared. That is the first equation that we cannot do anything about because time is not known for us to find the height. So let's move on to the second stone. So for the stone thrown upward, the stone thrown upward, what are the informations we have? We can still make use of second equation of motion. So let's go. Our distance is going to be rather from here to here, the distance covered before they meet. That will be h. The initial velocity is the speed at which it was propelled in the beginning, 42 meters per second. The acceleration is now moving in the opposite direction to the force of gravity. Force of gravity comes down. The acceleration here, because it is thrown upward, is in the opposite direction. We have negative g equals to negative 10 meters per second what? Square. So So 10 meters per second square. I think here time is also unknown. So let's move by substitution. From S equals to ut minus half gt squared, negative because we are talking about upward movement. H will be equals to u 42 times t, half of 10, then t squared. Here I will not be using negative 10 again because the negative have already taken effect from here. So I will only use the positive 10 in that regard. So h will be equals to 42t minus 5t squared, half of 10, 5t squared. That becomes the second equation. If you check the first equation, h in terms of t, h in terms of t, so if the h are the same on the left side of the equal sign, then the right side of the equal sign of the two equations will also be the same. So we are going to equate the two equations, right? That's equation 1 and equation 2. So picking from the first part, which will be 32 minus 5t squared is the same as 42t minus 5t what? Squared. I think we can still have a space. What I'm going to do is grouping of like terms. If I maintain the t here, and send this minus t squared to come to the left, it becomes positive. So negative 5t squared plus 5t squared becomes 0. So this means that I am left with 32 here equals to 42t. And making t the subject, we divide by what? 42. So from here, what do? We only pick our t equals to 32 divided by 42. Let's see, 32 divided by 42, that will give you 0.76 what? Seconds. So therefore, okay, so by conclusion, the stones will pass each other after 0.76 seconds. That is the second part of the question. But the first part was asking for the distance. So let's just say we substitute our t equals to 0.76 into any of the equations. We have equation 1, equation 2, they are all in terms of what? Age. So I think the shortest one is equation 1. That means age will be equals to 32 minus 5 times 0.76 all squared. So 32, if you multiply 5 by 0.76 squared, that will give you 2.888, and if you subtract that, we have 29.1. Let me pick one decimal place. Then therefore, the height at which the stone will pass each other will be 91 meters. So let's complete this to 3 decimal places. Then this becomes the height at which the stones will pass what? Each other. All right. Now, this is not the only way. We can also pick the distance we have as distance directly here without making 32 minus what? H. We just use the formula the same way it is, knowing this. So this will become equals to half of this. This will also be, then when you add the two equations, distance 1 plus distance 2 will now represent the 32. Then your right plus your right, as the first equation, the second side also equal. You end up getting the same value that we have for this one. You can try that and share your answer in the comment section. Thanks for watching. Like, share, comment, and subscribe.